natin. So, yung mga device, mga network device, so yung gagamit siya ng mga binary, use binary. Yakta natin yung 11010001 dot. So, yan ay mga binary. So, yun ang naiintindihan ng ating mga device. Specifically, the use of the IPv4 addresses. Dahil sa number binary system niya, so you can identify each yung mga address ng mga device. Then each address is made up of a string yan, of 32 bits. 32 bits, so divided into 4 sections called octets. Yan, so itong mga number system nito is 32 bits. Yan, sa 32 bits yan, divided into 4 sections. Kung makita niyo, meron siyang dot. So, 11010001 dot. Yun, so yun ay isang octet. Then, 10100101, yan, dot. O, isang octet ulit yan. So, each octet contains 8 bits or 1 byte. So, separated by a dot. For ease of used by people, so this data notation is converted to dotted decimal. Yeah, so pag i-convert natin itong mga binary numbers na ito into decimal, so ito yung equivalent niya. So yung itong unang device natin ito, so ito 209.165.200.225. So yun yung kanyang decimal number. So ito yung ating LAN A network addresses. Yan, so in binary form siya. At saka yung LAN B network address. So pag convert natin siya into decimal, so ito yung kanyang IP address. So 192.168.10.10. So yung isa ay 192.168.10.0. And also ito yung LAN B. So inasa decimal form siya. Yan. So, meron tayong video dito about how to convert between binary and decimal numbering system. Yan. So, this video will cover the following: the positional notation to review, the powers of 10 review, the decimal, the base 10 numbering review, the binary base 2 numbering review, and the convert an IP address in binary to decimal numbering. Share ko lang yung nasa akad yan. So, para ma-review niyo kung paano yung binary at ano yung decimal numbering system. Naririnig niyo ba ako? Malinaw ba yung yung signal ko?
Opo, ma'am.
Okay, so ito yung video about the binary and decimal numbering system. Okay, kita niyo yung screen?
Yes po.
In this video, I'm going to discuss binary to decimal conversion. But before I do this, I want to take a look at positional notation or place values. I have the number 2,168 here. If we look at the place values of the number 2,168, we can see that the place values have have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system. You can see that we have the number 2 in the 1,000s place, so we have 2 1,000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60, and we have 8 in the ones place for 8. So effectively, we have 2 1,000s, 1 100, 6 tens for 60, and 8 ones for 8. Now, when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0, the tens place 10 to the 1, the hundreds place 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2,168 then, in long form, we can see that effectively we have 2 1,000s, 1 100, 6 tens, and 8 ones, and 2,000 plus 100 plus 60 plus 8 totals 2,168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have 1 powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system, from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9,168, I'd simply replace the 2 here with a 9, and now I have 9 1,000s totaling 9,000 in the 1,000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, binary is a base 2 number system. There's only 2 characters, or 2 numbers, 0 and 1. So under the place values, we can only have zeros or ones. The place values go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times 2 times 2 is 8, 2 times 2 times 2 times times 2 is 16. That's 2 to the 4th power, place value of 16. The 32's place, the 64's place, and the 128's place. Notice that I extended the table to 8 place values. That's because 8 bits is an important grouping of numbers. 8 bits makes up a byte in computer processing. So now I have the place values for essentially 8 bits. If I want to write the number 168 in binary, I just have to find the corresponding place values and plug in either a 1 or a 0. So I'll go to the 128th place and ask myself, do I need 128 to reach 168? Yes, I do. So I'll put a 1 there. Now, do I need a 64? I already have a 128. If I add 64, I would get 192 because 128 plus 64 is 192. So the answer is no, so I put a 0. I still have 128 now. Now, do I need a 32? 128 plus 32 is 160. So yes, I could use a 1 here. $160. Do I need a 16? No, that would make 176, which would go over my target number of 168. I'll put a 0 here. What about an 8? If I add an 8, I'll hit the number perfectly. 128 plus 32 plus 8 is 168. I'll follow this up with zeros in the 4's place, the 2's place, and the 1's place. And 168 in binary equals 101010000. I now have 128, I have 132, and I have 8. And 128 plus 32 plus 8 equals 168. If we go to the next slide, you can see now that I'm now charged with converting the number 01101101 to decimal. If I want to go the opposite way and convert this binary number to decimal, all I need to do is plug it into the place values. I'll put it in here, 0, 1, 1, 0, 1, 1, 0, 1, and then add it up. I have a 64 and I have a 32. 64 plus 32 is 96. Plus I have an 8, that makes 104. Plus 4 makes 108. Plus 1 makes 109. This number converted to decimal is the number 109. Now let's look at a full IP address in binary. I'll go to my next slide. And you can see in this next slide, I now have a 32-bit IP address, 4 octets, or 32 bits total. If I want to convert this binary IP address to decimal, all I need to do is count up each individual octet. Let's start with the first one right here. We can see that 1, 1, 0, 0, 0, 0, 0, 0. 128 plus 64 is 192. Now, the next octet has 10101. Let's do that one. 0, 1, 0, 1, and then all zeros. If we count up the numbers, 128 plus 32 is 160, plus 8 is 168. The next octet is all zeros with a 1 in the last place in the ones place. This is easy. This is the number 1. All zeros and a 1 in the ones place makes the number 1. And then finally, we have a number here. I'll plug it in here into my table. And I have the number 011000101. We can see that 64 plus 32, we've already said, is 96. Plus 4 is 100. Plus 1 is 101. So the conversion of this binary IP address to decimal is 192.168.1.101.
Okay, so napanood niyo yung video about converting the decimal and the binary. Yan. So, sinong clear ba yung sa video? Raise your hands nga kung naintindihan ninyo. Lahat naintindihan nyo. Ayan. Kung hindi nyo masyado na-gets ng iba, so pwede nyo balikan yung video sa nat-akan. So, madali lang yung pagka-convert ng binary to decimal and decimal to binary. Yan. So, in binary positional notation, yan. So, positional notation means that a digit represents different values depending on the position and the digit occupies in the sequence of numbers. In the decimal positional notation system operates as shown in the tables below. Ayan. So, in decimal, so the radical is 10, and we have the position in number, and calculate, and then ito yung position value niya. For positional value, we have the decimal number na 1, 2, 3, 4. Kakalculate lang natin yan, multiply, then add, and then we get the result. Pagka naman in binary positional notation, we have the radix 2, and then ito yung position number, so 0 to 7, and calculate, ito yung mga position value natin. 1, 2, 4, 8, 16, 32, 64, 1, 28. And then, example, we have the binary number 1, 1, 0, 0, 0, 0, 0. Then, calculate nyo na yung may mga 1, multiply natin. Then, add, and then the results. Ito yung kanyang, yung binary to decimal. Ito yung mga example. Convert to binary to decimal. So, dapat alam niyo yung mga positional value. In decimal to binary conversion naman, so a binary positional value table is useful in converting the decimal IPv4 address to a binary. So, ito yung another way, yan, pag-convert ng decimal to binary. Decimal to binary. 168 is greater than 128. So yes, so yan, lagay tayo ng 1 in the position 128 position. Then subtract 168 to 128. So equals 40. So 40 is greater than 64. So no, so di natin kailangan yung 64. Greater than 0. In 64 position. Then move. Then is 40 is greater than 32. Yes. So lagi tayo ng 1. Then is 8. Okay. Minus ulit natin. 40 minus 32 is equals to 8. It is greater than 16. No. So 0 ulit. Then move. Yan, hanggang sa equal. O 1. So ito yung another way to convert ng decimal to binary. And so routers and computers only understand binary while humans work in decimal. So it is important for you to gain a thorough understanding of these two numbering systems and how they are used in networking. Cherish, may question ka? Cherish May?
Ay, sorry po ma'am. Hindi ko po natanggal.
Okay, hala ka may questions ka. Okay. Yeah. Okay, next, about the hexadecimal number system. Yeah. So, ano yung idea naman niya about hexadecimal number system?
Base 16 po.
Okay, base 16. What else? Ano pa? Matandaan niyo sa hexadecimal.
May letter po.
May letter. Okay. Yeah. So, in the hexadecimal and IPv6 addresses, and so to understand IPv6 addresses, you must be able to convert hexadecimal to decimal and vice versa. The hexadecimal is base 16 numbering system using the digits 0 to 9. And so the hexadecimal is 0 to 9 and then letters A to F. So it is easier to express a value as a single hexadecimal digit as a 4 binary bit. So hexadecimal is used to represent IPv6 addresses and MAC addresses. Yeah. So in a hexadecimal, in a IPv6 addresses, yung IPv6 addresses are 128 bits in length. Hindi kagaya ng IPv4. So, ang IPv4 ay 32 bits lang. So IPv6 is 128 bits. So every 4 bits is represented by a single hexadecimal digit. So that makes the IPv6 address a total of 32 hexadecimal values. Yeah, so the figure nito shows the preferred method of writing out an IPv6 address. So with each X, yan, makikita yung X ito, so representing 4 hexadecimal values. So about ito ay X, and so ito ay 4 hexadecimal values, is equals to 16 binary digits naman. Yeah. So about isang ganito ay 16 binary digits. So equals to 128 bits lahat yan. So each 4 hexadecimal character group is referred to as a hextet. So tinatawag naman siyang hextet. Yung isa ay octet. Ito naman ay separated by colon. Okay? IPv6. Okay, so ito naman yung video converting between hexadecimal and decimal numbering system. Makikita niyo na yung screen, video.
Yes po, ma'am.
Kasi kayo, medyo nabagal lang.
Hexadecimal, or hex for short, is a base 16 number system. It uses 16 symbols, the numbers 0 to 9, as well as the letters A to F. It is based on powers of 16. If we follow the same procedure used for converting binary to decimal, we can write out the place values or positional notation for the hexadecimal number system as well. Here we can see the first 4 place values based on powers of 16. This is 16 to the power of 0 or 1. Any number to the power of 0 is 1. This is 16 to the power of 1 or 16. This is 16 to the power of 2 or 16 times 16, which equals 256, and this is 16 to the power of 3, or 16 times 16 times 16, which equals 4,096. Let's look at the decimal and binary equivalents of each hex symbol. These are the decimal equivalents. Note that the hex symbol A is equal to decimal 10, hex B is equal to decimal 11, and so on until we get to hex F, which is equal to decimal 15. Here are the binary equivalents. Note that each hex symbol can be used to represent a 4-bit binary number. Given that 8 bits is a common binary grouping, we can represent an 8-bit binary number using just 2 hex symbols. In this first example, let's look at converting hex 28 to decimal. First, I'll write out the positional notation for the first 2 powers of 16, then insert the hex symbols below the corresponding place values, 2 under 16 and A under 1. Then I'll multiply each hex symbol by the place value that it's under and add the results together. So we get 2 times 16 plus A times 1. That gives us 2 times 16 plus 10, which is the decimal equivalent of A in hex, times 1, which gives us 32 plus 10, or 42 in decimal. Multiplying or dividing by 16 isn't always easy when doing hex to decimal conversions. Usually it's easier to convert the hexadecimal or decimal value to binary first, then convert the binary number to decimal or hexadecimal. Let's convert decimal 197 to hex. First, I'll begin by converting 197 to an 8-bit binary number. Here I've drawn out the first 8 place values of the binary number system. We need to find out what combination of these place values adds up to 197. I'll begin by writing 197 on the left side, and starting at the left, if the place value is equal to or less than this number, I'll put a 1 under it and subtract it, and if it's greater, I'll put a 0 under it and move to the next place value. Since I can subtract 128 from 197, I'll put a 1 under it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0. Under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0 under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract
Nawala lang, umaga lang.
convert decimal 197 to hex. First, I'll begin by converting 197 to an 8-bit binary number. Here I've drawn out the first 8 place values of the binary number system. We need to find out what combination of these place values adds up to 197. I'll begin by writing 197 on the left side, and starting at the left, if the place value is equal to or and if it's greater, I'll put a 0 under it and move to the next place value. Since I can subtract 128 from 197, I'll put a 1 under it and subtract it, and that gives me 69. I can subtract 64 from 69, so I'll place a 1 under that and subtract it. That gives me 5. 32 is too big, so I'll place a 0 under that. 16 is also too big, so that gets a 0. 8 is also too big. But when I get to 4, I can subtract binary 110000101. Next, I'll convert the 8-bit binary number to decimal by first splitting it into two 4-bit binary numbers. And then I'll rewrite the first 4 binary place values above each half. So here I have 1, 2, 4, 8, and then repeated on the left, 1, 2, 4, 8. Then I'll convert each half to decimal and then each decimal to its equivalent hex value. On the left side, we get 8 plus 4, which equals 12, and on the right side, we get 4 plus 1, which equals 5. If we convert those to hex, 12 decimal is the equivalent of C in hex, and 5 decimal is the equivalent of 5 in hex. Therefore, 197 in decimal is C5 in hex, or it can also be written with a 0x preceding it to indicate that what follows is written in hexadecimal. Lastly, let's look at converting from hex to decimal, but this time we'll convert to binary first instead of going straight to decimal like I did in the first example. I'll convert the hex 9F to decimal. First, convert each hex symbol to its 4-bit binary equivalent. I have hex 9, which is the same as decimal 9, and that gives me 1001. And then I have hex F, which is equivalent to decimal 15, and that gives me 1111 in binary. Next, I'll combine them into one 8-bit binary number. So here I have the first 8 place values in binary, and then I'll convert to decimal, and that gives me 128 plus 16 plus 8 plus 4 plus 2 plus 1, or 159 in decimal. There are often several ways to approach converting between number systems. You should use the one that works best for you.
Okay, so natawid din natin yung video. Kasi na kayo medyo mabagal, medyo maula kasi dito sa amin. Ayan, so naintindihan nyo yung about the hexadecimal?
Yes po, ma'am.
Ayan. So raise your hands nga kung sino nakaintindi. Clear? Ayan. So kung medyo hindi malinaw, so kanya rin balikan yung video doon sa inyong NetAcad. So hindi ko i-discuss yung next. So magpapost na lang ako sa Google Classroom ng module practice quiz for attendance, yung 5.3.2. Okay, so next module naman natin is about the data link layer. So madali lang din naman itong data link layer. Okay, nakita niyo na yung slides? Presentation?
Kita na po.
Okay. And next, about the data link layer. So, tatandaan niyo ba about yung data link layer? So, ilang layers siya sa ating OSI model? Discuss ko sa inyo yung physical layer. Yung sunod, the data link layer. So, ito yung layer 2. Okay, so the objectives explain how media access control in the data link layer supports communication across networks. DMAC. So, yan. So, 3 topics lang tayo dito sa purpose of the data link layer, to describe the purpose and function of the data link layer in preparing communication for transmission on a specific media, then the topologies, to compare the characteristics of media access control, or yung MAC methods on WAN and LAN topologies, and the data link frame. So, describe the characteristics and functions of the data link frame. Okay, so first topic, purpose of the data link layer. Yeah, so in the data link layer on the OSI model, yung layer 2, so ito yung prepares a network data for the physical network. So the data link layer is responsible for communication between end device network interface card. So it allows upper layer protocols to access the physical layer media and encapsulates layer 3 packets. Layer 3. So sa layer 3, na-encapsulates na packets or IP into layer 2. Layer 2 naman ay yung frame. Makatatin sa ating figure, ito sa ating display na figure. So, take example of how the data link layer adds layer 2 Ethernet destination and the source and IC information to the layer 3 packet. Yan, ito. We have the destination and IC and source and IC. So, yung layer 2. Oh, sorry. And then, the add yung layer 3, the packet naman so sa source IP and destination IP. So yung L2 at L3, layer 2 and layer 3. And also the data link layer, isa sa mga functions ito, so it performs error detection and rejects corrupt frames. Okay, so the IEEE 802 LAN and MAN standards are specific to the type of network. So the data link layer consists of 2 sub-layers. So the logical link control or LLC and the media access control or DMAC. So ito yung ating layers. So, ito yung first layer natin, the physical. And then the second layer, layer 2, data link. And then meron siyang 2 sublayers, so LLC sublayer and SNAP sublayer. Then ito yung layer 3 natin. Ang layer 3 is the network. And in the LLC sublayer, it communicates between the networking software and at the upper layers, yan, and device hardware at the lower layers naman. Yan dito. So dito ay yung hardware, o sa taas ay yung software. The MAC sublayer naman is responsible for data encapsulation and media access control, the MAC address. So providing access to media, so each network environment that packets encounter as they travel, yan, from local host to remote host, can have different characteristics. So the packets exchanged between nodes may experience numerous data, link layers, and media transitions. So the router interface to encapsulate the packet into the appropriate frame. So at each hop along the path, a router performs 4 basic layer 2 functions. So it accepts a frame from network medium, then they encapsulate the frame, expose the encapsulated packet, then re-encapsulates the packet into a new frame, and then forwards the new frame on medium of the next network segment. So ang layer 2 kasi, o yung data link layer, so nag-encapsulate siya ng frame. Dito. The data link layer standards. Yan. So, tayong mga engineering organizations that can define open standards and protocols applied sa network access layer. It includes the IEEE, or Institute for Electrical and Electronic Engineers, or IEEE, the International Telecommunications Union, the International Organization for Standardization, ISO, and the American National Standards Institute, or ANSI. So ito yung mga logo, yan, pag nakita kayo ng mga ganitong logo, so ito yung mga data link layer protocols. And next, the topologies. So, kung pamilya na, anong alam niyo yung mga topologies o topology? May natandaan pa kayo? Topology? Wala pa? Yes. So, kung natandaan niyo yung ating diniscuss, we have physical and logical topologies. And the topology of a network is the arrangement and relationship of the network devices and the interconnections between them. There are 2 types of topologies when describing LAN at saka WAN. So we have the physical topology. It identifies the physical connections and how end devices and intermediary devices, kaya ng mga routers, switches, and wireless access are interconnected. So yun namang logical topology, so refers to the way a network transfer frame from one node to the next. And so identifies the virtual connections between devices using device interfaces and also the IP addressing scheme. Yes, makita natin din yung interface, so naka-connect at ano yung IP address. So there are 3 common physical WAN topologies. Yung una is the point-to-point. It is simplest and most common WAN topology. It consists of a permanent link between 2 endpoints. Then we have the WAN hub and spoke. So similar to a star topology. where a central site interconnects branch sites through point-to-point links. And then we have the mesh. So provides high availability but requires every end system to be connected to every other end system. Pag sinabi natin point-to-point one topology, is directly connect two nodes. Yan. So limited lang sa dalawang nodes. So the nodes may not share the media with other hosts. Yan, because all frames on the media can only travel to or from the two nodes, so point-to-point protocols can be very simple. Yan. So meron na lang node 1 at saka node 2. So kaya point 1 topology. Okay, the LAN topologies, or the local area network. So in multi-access LANs and devices or nodes are interconnected using the star or extended star topologies. Okay, so we think star topology and extended star topologies. So ito na tsura niya. So ito ay easy to install, very scalable, and easy to troubleshoot. Pagkaganyan na inyong topologies. So the early Ethernet and legacy token ring technologies provide two additional topologies. So ay mga legacy na. We have the bus topology and ring topology. So sa bus, so ito yung tura niya. So all end systems chained together and terminated on each end. So sa ring naman, each end device is connected to its respective neighbors to form a ring topology. Okay, next, so the half and full duplex communication. So understanding duplex communications, so it is important when discussing LAN topologies because it refers the direction of data transmission between two devices. So meron tayong two common modes of duplex, the half duplex and the full duplex communication. So in a half duplex, so both devices can transmit and receive on the media but cannot do simultaneously. Yan. So only allows one device to send or receive at a time on a shared medium. And use on WLANs and legacy bus topologies with Ethernet hubs. Yan, so half duplex. Kumbaga, server muna yung magsesend, receive, o pwede naman yung hub naman yung mag-send. Yung server yung mag-receive. So, isa lang, one at a time. Pagka naman full duplex, so both devices can simultaneously transmit and receive on the shared medium. So Ethernet switches operate in full duplex mode. For example, baga ang server at saka switch, so pwede silang mag-send ng sabay, pwede maka-receive din ng sabay. So full duplex. Okay, the access control methods. So the Ethernet LANs and WLANs are example of the multi-access networks. A multi-access network is a network that can have two or more end devices attempting to access the network simultaneously. Okay, so there are two basic access control methods for shared media. Ito yung contention-based access at saka controlled access. So, it is a contention-based access. So, all nodes operating in half duplex, so competing use of the medium. So, ito yung mga examples of contention-based access. The CSMA-CD o Carrier Sense Multiple Access with Collision Detection. Ito na ay legacy on bus topology Ethernet. And then merong carrier sense multiple access with collision avoidance, or CA. So as used on wireless LANs. Yung controlled access naman, so deterministic access where each node has its own time on the medium. Used on legacy network, such as the token ring and the ARPANET. Ginamit yung control access using the token ring. Okay, the CSMA or contention-based access. CSMACD, so used by legacy Ethernet LANs, so operates in half duplex mode where only one device sends or receives at a time and uses a collision detection process to govern when a device can send and what happens if multiple devices send at a time. For detection process, so device transmitting simultaneously will result in a signal collision on a shared media. And also devices detect the collision and the devices can wait a random period of time and retransmit data. Yun namang so detection. Okay. Ito naman ay yung the avoidance, carrier sense, multiple access with collision avoidance. It is used by IEEE 802.11w LANs, also operates in half duplex, and uses a collisions avoidance process. So the avoidance process, so when transmitting, devices also include the time duration needed for the transmission. So other devices on the shared medium receive the time duration information and know how long the medium will be available. Yes, so ito yung collision detection is a collision avoidance. Okay, next, so last topic about the data link frame. So the data link layer so prepares the encapsulated data. So for transport across the local media by encapsulating its header and a trailer to create a frame. So yung layer 2, so yung encapsulate niya ay yung frame. So yung data link frame has 3 parts. So the header, data, and trailer. So the fields of the trailer, head and trailer vary according to the data link layer protocol. So the amount of control information carried within the frame varies according to access, control information, and logical topology. Yes, ito yung mga frame fields. Yeah, so meron tayong 3 parts nga ng frame, data link frame, so yung header, data, and the trailer. Ito yung mga fields, so we have the frame, start and stop. Yeah, so identifies beginning and end the frame. We have the addressing, so indicates source and destination nodes. The type identifies encapsulated layer 3. Control, so identifies flow control services. And then the data, so contains a frame. And also the error detection. So it is used for determine transmission errors. Ito yung mga frame fields. So the data link layers, it provides the addressing used in transporting a frame across a shared local media. So this device addresses at this layer are referred to as the physical address. Layer 2, the data link layer. It contains in the frame header, so used only for local delivery of a frame on the link, then updated by each device that forwards the frame. So, makita natin ito sa ating figure. So, meron tayong yung function ng layer 2 and layer 3 addresses. So, at itong ating source original source ng ating PC1, yan, kapag ka tayo ay yan, yung ating IP packet travels from host to router. Yan, una muna yung host, yung PC to router, then router to router, and then finally yung router to do sa ating final destination sa host. So each point along the way, the IP packet is encapsulated in a new data link frame. So each data link frame contains the source data link address of the NIC sending the frame, and also the destination data link address of the NIC receiving the frame, yung final destination. Yes, so yung may layer 2, layer 3, host to router, router to router, then router to the host. So, na-encapsulate yung data link frame. Okay, so the logical topology and physical media determine the data link protocol use. Yeah, so to include the Ethernet, the 802.11 wireless, of the PPP of point-to-point, the high-level data link control, and the frame relay. So each protocol performs media access control for specified logical topologies. Okay, so that's all about the data link layer. Yan, so para mas maintindihan ninyo, yan, so may mga animation dun sa .acad. Yan. So, paano yung layer 2 mag-encapsulate papunta dun sa final destination. So, from source to final destination. So, click nila yung mga animation doon. Okay? So, what did you learn in this module? I read nga, si Cristel Magtibay.
Lahat po, ma'am.
Sige, hanggang doon lang sa half duplex. Simultaneously.
Sige po. What did I learn in this module? The data link layer of the OSI model layer 2 prepares network data for the physical network. The data link layer is responsible for network interface card to network interface card communications. The IEEE 802 LAN or MAN data link layer consists of the following two sublayers, LLC and MAC. The two types of topologies used in LAN and WAN networks are physical and logical. Three common types of physical WAN topologies: point-to-point, hub and spoke, and mesh. Half-duplex communications exchange data in one direction at a time. Full duplex sends and receives data simultaneously.
Okay, so next, si Cherish May.
Ma'am, medyo po nagtitigil. Saan po nagtigil?
Ano kaya ka? In contention base. Start ka doon.
Okay po. In contention-based multi-access networks, all nodes are operating in half-duplex. Examples of contention-based access methods include CSMA or CD for bus topology Ethernet, LANs, and CSMA or CA for WLANs. The data link frame has three basic parts: header, data, and trailer. Frame fields include frame start and stop indicator flags, addressing type control, data and error detection, Data link addresses are also known as physical addresses. Data link addresses are only used for link local delivery of frames.
Okay, so that's all. Yan, about the data link layer. And so again, so meron ulit tayo itong module practice quiz. Yan, so sasagutan niyo yung 6.4.2. Yan, so ano yan, sa Google Classroom, and sa for attendance, sasagutin niyo yung dalawang module quiz. Sa module 5 and sa module 6. Okay? Kumunti na tayo, tutuwag na tayo ngayon. Okay, so marami pang hindi nakakagawa ng activity 1 and 2. So activity number 1, may 5 pang hindi nakasubmit. Ipakagawa na. Sa isa naman ay sa activity number 2, so remind ko lang ha, kung hindi nakakagawa, wala tayo, sa midterm na tayo, semi-finals na. Yan, so sa activity number 2, 7 pa yung hindi nakakagawa ng activities. So gawin nyo na agad yung activities, ha? So dyan, mga final project na yung gagawin ninyo. Okay, so may questions pa?
Wala na po.
Yan, so kung wala na kayong questions, yan, so thank you for attending our class today. Yan, yan. So pwede na kayong mag-leave and gawin nyo na yung mga module quiz. Okay?
Thank you po.
Thank you po, ma'am.
Thank you po.
Thank you po, ma'am.